Hi, everybody, and welcome to this week's episode of Echo Live, coming to you from the Michigan Science Center's Echo Distance Learning Studio. My name is Anna, and I am so excited to talk to you today about the science of bubbles. Now, we've all probably made bubbles before, whether it is outside or maybe in the bathtub, but I want to talk about a little bit of the science that goes into creating a good bubble, because in my opinion, there are definitely better bubbles than others. So I'm going to give you some secrets to what I think makes a great bubble recipe, and we're also going to make some bubbles in a pretty unconventional way. Now, rather than blowing a bubble with my mouth, like maybe we've done before with Bubble Solution and some of those fun, kind of funky shaped bubble wands, instead, I'm going to use a very scientific material in order to generate the gas or the air that is going to fill my bubbles. Now, I brought with me a material today, which we love to talk about here on Echo Live. I've got a big old beaker full of dry ice, and you may not even be able to see it in my beaker right now because there's so much frost collecting on the surface. Now, if you remember dry ice from any of our past episodes of Echo Live, it looks a lot like regular ice. You can see a piece of it right here in its solid form. But dry ice is not made out of water like the ice cubes that we get out of our freezers at home. Instead, this stuff is made out of carbon dioxide, that same substance that you exhale when you take a big, deep breath. You can try that with me at home. Deep breath in and out. We know that our human body exchanges oxygen in the air to use it for all sorts of things, and then we exhale carbon dioxide as waste. Now, in order for dry ice, frozen carbon dioxide to exist, it has to be super cold, which is why you noticed I did not touch it with my bare hands. Instead, I used a pair of tongs. Now, this stuff has to be negative 109 degrees Fahrenheit, which is super, super cold. Now, the interesting thing about dry ice, and the reason that we call it dry ice, right, is that dry ice never melts. It never exists as a liquid, at least not at regular atmospheric pressure. Instead, we say that dry ice does something called sublimation, meaning that dry ice turns from a solid directly into a gas, skipping that liquid phase altogether. When it does this, those molecules of carbon dioxide start to take up much more space. So if you look at these tiny blue dots inside our ice cube here, now that could be made of water ice or dry ice, when they sublimate or become a gas, they spread out, they take up more space. And that is exactly what we are going to utilize today in order to blow our first bubble. Now, rather than creating a soap bubble, I'm actually going to create a pseudo bubble inside one of these balloons. Now, we do want this dry ice to sublimate a little bit more quickly than it is just sitting out in the air. And the best way I know how to do that is actually to introduce some warm water. So when the dry ice touches the warm water, that process of sublimation goes more quickly. It's just to speed up this episode just a little bit. So I'm just going to take a couple pipettes full of my warm water here and squeeze them into the balloon. And what we're going to be observing or watching is how much more space dry ice takes up when it is a gas, when it is carbon dioxide in the air, versus in its solid form, like we see down here on the table. So we'll just go ahead and take another small piece of dry ice, but let me go ahead and zoom in so we can all get a close look at this experiment in action. But I'm just going to go ahead and take one small piece of dry ice, drop it right into our balloon. Now, of course, I practiced this earlier. It went great. And go ahead and make sure our balloon is fully open here. Maybe pick a smaller piece, a little bit easier to fit through our opening. There we go. And we're just going to drop it down inside. Now, if we seal off the balloon, making sure that all of that carbon dioxide gas is trapped inside the balloon rather than being able to leave through the opening, we can watch as that gas starts to expand. So the balloon is tied off. I'm not introducing air from my breath or from anything like a balloon pump. Instead, the actual act of sublimation is what is starting to fill this balloon with air. This process works great, although a little bit slow. So we're going to go ahead and we'll just let this piece of dry ice continue to sublimate off to the side. And by the end of our episode here, once that piece of dry ice that's still in its solid form inside, I can feel it. Maybe you can even hear it. Once it's completely sublimated, we can check again to see how much more space that dry ice takes up as a gas than it did as a solid. but this isn't the most exciting type of bubble that I can create here. Instead, let's give it something with a little bit more pop. Now, this is one of my favorite dry ice demonstrations, and it demonstrates the exact same concept. Now, instead of trapping the expansion of this gas inside something stretchy or elastic like the balloon, instead, I'm going to drop it down inside something that's a little bit more rigid, like this coffee canister. Now, just like the balloon, I've added in just a small amount of warm water to the bottom just to get that process of sublimation going a bit more quickly. And we're just going to take a few pieces of dry ice and drop them down inside. Now I can see fog starting to form. In just a moment, I'm sure you'll be able to see the fog as well. There we go. So that process of sublimation is definitely happening. I can hear it. You probably can't hear it from home, but I can hear that process of sublimation happening. And there's actually some bubbles starting to form in the water. But let's see what happens when we trap that expansion inside something a little bit more sturdy than our balloon. Watch our lid. And it goes pop, right? So as those gases expand, as we fill our quote bubble this time, we can see that when the pressure becomes too great, as those gases expand, our lid goes pop right off. Now, we want to talk about soap bubbles though. So I have another dry ice experiment that's a fun classic. And we've just got a pretty funky looking container here. This is called an Erlenmeyer flask, but it's got a hose attached to it. So same setup as all of our other experiments so far. We are going to power our bubbles through some dry ice action, through some sublimation. But for this to work, we're just going to let all of that gas flow out the end of our tube here. And we're going to dip it down inside my bubble concoction. Now I've created what I think is the best bubble solution. Now, if you've made bubble solution at home and not just bought it from the store, you might know that one of the main ingredients is, of course, water. So this was a cup of water, and I've added something pretty simple. I've added some dish soap. Now, a lot of people like to argue that certain brands of dish soap are what make a good bubble solution, that they have a preference for which soap brand they buy. But I'm here to tell you that the brand of soap is not the secret ingredient behind the best bubble solution in the whole world. What makes for a good bubble is this ingredient right here. This stuff is called glycerin. Now, glycerin is awesome for bubbles, and I'm going to show you the reason why. But in order to show you why you need glycerin, we need to take a look at the chemical composition of a bubble. So another slide coming your way. Now, I've got two images of different bubbles. The one on the left is bubble solution made of just water and soap. So the reason a bubble pops is not because something sharp touches it or stabs it like a pencil or a knife. It's actually that the water on the surface of the bubble starts to evaporate. So if we look at the image on the left, the bubble solution that's made of just water and soap, you can see that there is lots of space left between those soap molecules for the water to evaporate. Look at the number of arrows. Look at all of that space that allows the water to evaporate, to change forms, which would cause the bubble to pop. Now on the right, we've added those molecules of glycerol, which is the active ingredient in glycerin, that bottle that I showed you just a second ago. Now in this chemical structure, you can see that the glycerol actually gets between all of the molecules of soap and therefore gives the water much less space to evaporate from. So bubble solution that has both dish soap and glycerol is much more effective. It slows down that process of evaporation, and it makes you really good bubbles that are pretty difficult to pop. Now, glycerol is a type of oil, and there are also oils on the surface of your hand. So when a bubble touches your hand, again, it's not popping because your hand is sharp or covered in tons and tons of tiny little knives. Bubbles pop when they touch your hands because either the surface of your hand will dry out the bubble, it will speed up that process of evaporation, or because the oils in your hand actually interfere with the chemical composition of the bubble. So what is one to do? If one wants to hold a bubble, perhaps keep a bubble as a pet, can we do it? The answer is yes, you can. Now I have a really simple pair of gloves here. I actually got these gloves at the dollar store, so you can actually get a pair just like this winter. And these are actually going to prevent the oils on the surface of your hand and the dryness of your skin from popping the bubble. So let's add a little bit more dry ice to our Erlenmeyer flask here, get a little bit more power behind our bubble blower. Plug our lid, and let's take a look at what happens when I blow a bubble and I let it touch my hand this time. I can actually hold on to this bubble for as long as the air doesn't cause the bubble surface to evaporate. Now, of course, you have to be gentle, right? If I squeeze it, there it goes. But using just a very simple pair of gloves is actually benefited by that chemical structure we talked about. So we're not causing the bubble to evaporate because of the dryness of our skin. The oils on our hands are not causing any interruption in that chemical structure. And we have pretty much the perfect bubble solution and the perfect mechanism for being able to hang on to these bubbles for a pretty long time. Now, this just about brings us to the end of our episode of Echo Live here today, but this is a really fun experiment that you can try at home. And if you want to turn it into a true experiment, how about introducing other things into your bubble solution? Is there anything you have around home that you think would make an even better bubble solution than the one that I showed you here? Now, of course, we told you we'd take one last look at our bubble before we signed off today, and there's still a very small, solid piece of dry ice in this bubble. But look just how much air we created, even without using our own breath to fill up this balloon. Again, it was just water and a tiny little piece of dry ice inside. And look at that expansion. So, of course, thank you all so much for joining today's episode of Echo Live. We will be back here next week with another episode thanks to the support of Denso and the Michigan Space Grant Consortium. They have funded Echo Live through the rest of this year so that we can teach you even more exciting experiments to try at home or in your classroom. If you have any suggestions for experiments that you would like to see us try, if you have favorites that you'd like for us to bring back, maybe something related to fire or explosions, tell us in the chat. And thank you all again so much for